we're going on in English because we are not only did a technical upgrade this year, we also did an upgrade from national to international speakers. And our next guest comes from the Netherlands. He graduated with a Bachelor of Science in Game Technology, and he started his career as, you guessed it right, Minecraft plugin developer in 2015. And right now he's working on his in his own country as a co-founder at Wickel. What that is, he will tell you on his own. So I think we don't need other words, and let's greet our next guest with his mother language. Heel bedankt voor je aanwezigheid and welcome Finn van der Heide. Hello.
Hey, thank you so much for the nice introduction, and you really learned studied the Dutch sentence a lot better this time. I can hear it.
Thanks.
But yeah, I'll be talking about Timebenders and how we are doing the rewinding of time in it. So first of all, a little bit more about myself. Well, I'm Finn van der Heide. I live in Amersfoort right now. This is my home in the background. I have an office in Utrecht together with Guido, and he's the founder of Oogbaard. And with Oogbaard, I'm the producer and developer. It's a small indie studio for which we make games that have like a really low boundary of entry. So it's really easy to get into, but have a lot of depth, so you can like combine a lot of things and continue learning more about the game for a long time. I also am co-founder of Wickel, and with Wickel we create software. It sounds kind of boring, but we really do a lot of interesting stuff like AR, VR, serious games, game porting. We also work with a company on some brain scanner software. So it's a really broad, state-of-the-art work that we do there. So it's really cool to stay on point and keep learning new things. I'm also a guild leader in Elder Scrolls Online. So if you're interested in joining an amazing social guild on the EU PC mega server, be sure to hit me up. But before we go into how we are doing it, you first need to know what is time. So I did a quick Google search and found a Wikipedia article, of course, about time. And they define it as the indefinite continued progress of existence and events that occur in an apparently irreversible succession from the past through the present into the future. So to break it up a little bit, make it more digestible, what it says is that time flows forward, the past is set. So everything that has been done and has happened cannot be changed anymore. The present is controlled directly, like we can now do things. Like if I wave like this, it's happening, I'm controlling it, this is happening, this is what is going on. But also like chemical processes and everything else is controlled currently as it's happening. And the future is all controlled indirectly by the past, the present, what I'm doing, what you're doing, what's happening around me in the world. That's what's controlling the future. And that flow is in there. Yeah, but what if we could go back in time? Is what we asked ourselves. Like, what could we do? Like, okay, maybe like I have a nice glass of water here. What if I drop it on the ground? It breaks. It's a big mess. I don't want to clean it up. Let's just go back in time and never drop it. It's an easy way to like solve small mistakes. You can also solve bigger mistakes, but you can also it's kind of different. You can use the knowledge that you've gained right now in the past. So we now know a lot about like weather systems, electricity, how those kind of things work, a lot of scientific things. If we go back to the medieval times, we would be a god. We would know so much. We could help an empire like grow to immense proportions. We would be almighty. Those are things that stick in your mind. Like, what can we do? Well, now talking more about like abstract time and what could happen and whatever. We want to create games. So let's first see what's happening right now. Like, what games have been created. So in the single player domain, it's most of the time it's global rewinding. So instead of like certain objects being put back, like it's not like I'm going into a time machine and going back in time and I'm still the same, but the whole world is different. No, everything gets put back. Everything is equally rewinded. So an example for that is Braid. This is a really short clip, and it shows that the main character that you can see over here in the middle of the screen is being hit by the enemy, and because of that he dies. I'll show. Oh, it moves back. I need to click on this. He dies. He can press a button, and the whole world's just rewinded. You can also see that yourself, the enemy, but even the background. If you look well at the background, you can also see that it's rewinded. Like the sun turns one way, time goes back, turns the other way. Like the whole world is entangled in this time and everything is put back. Another example, a little bit bigger of a title, is Prince of Persia, Sands of Time. In this game you can also rewind to go back in time. Currently the player wants to climb this tower. Don't ask me why, but he wants to climb the tower, he wants to go up higher and higher. But then he makes a mistake, drops to the ground, and his character is dead. That's of course not what you want to happen. So you rewind back in time and try to find a position where everything is safe again. You can see a little bit of the flames. You can see the character on the ground that approach the body on the ground. They are also rewinded and everything is put back. And now he was in a safe position again, where he can stop the rewinding and continue playing. Well, that's more of a single player approach to it. We can rewind everything because there's not too much. You're not annoying a lot of people. It's controlled. Because of that, in multiplayer games, they've done it a lot differently. So instead of doing the whole world rewinding, everything rewinding, it's very compacted. It's just that the user that is going back in time, only they are being put back in time. The rest of the people are still doing whatever they want, are still continuing in time, and everything is still fine in there. But just the player itself is put back in time. The most obvious example that literally everyone talks to us about the first time they hear about this is like, oh, it's like Tracer, right? Well, in a way. In this case, Tracer is attacking the Widowmaker, drops a bomb, and goes back in time. Now, back in time, Tracer is back in cover, is back in safety, and does not get hit by any explosion that's happening on the moving vehicle. Another example that probably a lot of people know is from League of Legends. There's Echo, and his ultimate also sets him back in time. So in this case, you can see him. You see this trail behind him, and that's where like gives an indication where he will go if he uses his ultimate. But right now he's going in. You see the enemy team here, a lot of enemies. He's going in deeper, and then he sees on the left, he sees another enemy, and he's like, no, I'm way out of position. I need to be gone here. Get me out of here. So he uses his ultimate, goes back in time, and is now behind his friend, moving to the turrets, minions, and back into safety. Everything is fine again. So if we compare them, global time is mostly about like fixing mistakes, making sure you don't die. But it also has a thing that of full control. You know where it's going to end. It's not that you yourself are going back, but you don't know what the rest of the people are doing. You know that everything in the world will be exactly how it was a previous moment. That gives you a lot of control, but also limits you in a way. So that's where local rewinding, it also creates advantages. Like in the Tracer clip, it moves you forward, you can kill someone and go back to safety. But it only gives the partial control. If in the meantime someone saw that you did that you went in and dropped a bomb in the hallway, you would teleport back in time and be in the hallway, then you would go dead and you would be like, it would be game over. So there's more risk to it, but also potentially more reward. So we ask ourselves, why not both? Why can we not have both in one game? It would be great to have the whole game based around time mechanics and not just in a multiplayer situation and not just having local rewinds. So that's where we came up with Timebenders. In Timebenders, it's an online time combat game. So you're in an arena and you're fighting alone or together with your friends, using time control in your advantage to try to win from the enemy. So I'll show a short preview video. We're still in development, keep that in mind. But to give you an idea about the game that it is right now. The terrain is also fully destructible, and that can also be rewounded again. So this is a global rewind, everything is put back in time. You see local rewind, creating advantage for you. Freezing time is out of scope for this talk, but also something we have enabled. Making yourself back alive again, giving you a second chance. You can create your own spell sets, so it's not set up in a way where you need to pick a champion or a hero. It's all free, up to you. It's multiplayer. Keep that in mind. Global rewind and multiplayer. Like, we enable everything together, and it still plays well. It's not structured in a way where it blocks you from doing what you want to do. Yeah, you can also rewind your dead allies. You don't have to just rewind yourself. Rewind your friends. So yeah, currently we're working on Timebenders, but what it really, first of all, what you need to do is you need to design how you want it to work, how you want it to look. So since the time rewinding is such like a core part, the core principle of the game, we first need to look at what are the goals of the rewinding. Well, we want everyone to feel like really powerful. It's not like you're a weak human in a world and you need to be careful because when anything happens, you die of like disease or something. We want you to be powerful. You can destroy terrain. You can almost destroy big parts, destroy enemies. Do it quick, but also have a chance of like saving yourself, creating advantages, giving you that second chance. Are you dead? No, not yet. I'm still alive. I'm still coming for you. I'm still killing you. So for this, we need to look at like the definition of time and morph it a little bit. We need to like combine local time and world time in it and enable a way to rewind the time. Like, we keep it the same, that the world time naturally flows forward. It naturally wants to go at a normal pace, at like the pace of 1 is what we call it. It's just normal speed forward. But we can change the rate of flow. We can make it a half, and then the whole world and everything in it goes at half the speed. We can put it at 0. The whole world freezes. It's not a really interesting game, but it's something to keep in mind. We can freeze the simulation. We can freeze the world. We can freeze the time and anything in it. And of course, if it becomes negative, we can go back in time. If it becomes -1, we are going back in time at the same rate the world would normally be simulated. Local time in this perspective, we kept it as part of this global time. It's still inside of the world time space, but on a scale that's smaller. So just single objects, single players. But I'll talk more about that, about the technical details, and it will explain better how it works. Well, a naive way of doing this is, why not record the position of everything every frame, and when the time goes forward, so when we're simulating, just at the end of the frame drawing, get all the positions, we're fine. We can simulate all the positions, put everything back again. When we go backwards, the other way around, every frame we set it back. We have all the information, so we can do that. So let's see at this ball. You have the blue ball, and the red simulates the ground. And on the left side, you have a buffer that shows, for this case, the position. It's now 5 above the ground. And we go 1 frame forward, ball drops, and we're now 4 above the ground in the buffer. 3 above the ground, 2, 1, it hits the ground. And if we continue, it stays on the ground. So in the buffer, it keeps adding zeros. This is all normal. We're just storing data. It's like making a video. You just record everything that's happening. Nothing spectacular. So if we go back in time, we literally just go back frames. So we go 1 frame back. It's still on the ground because it was on the ground. It was been laying on the ground for a couple of frames. So this is what we want. It still needs to be on the ground, still needs to be on the ground. And then if we go 1 more frame back, now it moves off the ground again. This is not in a simulation. Time is going backwards. Keep that in mind. Nothing is moving forward. There's no interaction possible. Nothing is possible. Everything is just how it was. And nothing changes. So we're going back further, 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 and we're back at the start again. This is all the data we stored, and this is just rewinded backwards. Okay, we can now play it back. So keep in mind, we're not playing the time forward. We're just playing it back. Like a video, you record it, and you go back to the beginning again and press play again. We're not continuing playing time. We're doing a playback. So of course, we're still setting values. So it's still exactly at how it was. Nothing is changing. It goes forward, it hits the ground again. Everything is fine. Okay. So let's rewind a couple steps from there. It hits the ground and rewind a couple steps. It's now at the height of 3. What if we want to continue time? So instead of time being -1, we go to +1 again. So the ball is going to fall again. My question for you, just think about it for a second. If we start continuing playing time, what will the position of the ball be? Like, it's falling, but what will the position of the ball be? Will it again be 2, 1, 0, 0, 0? Or will it be something else? I'll give you a second to think about it. Can I get a drink? If you said 2, then I'm really sorry, but you missed something. Because it will be 2.5. And now you might be thinking like, okay, why 2.5? Okay, the half part is a little bit of an arbitrary value, but it's not going to be 2 because over here it was laying on the ground. So the velocity has been cancelled. It's 0. It's not falling anymore. It's stationary on the ground. So if we let it drop from here again, then it needs to accelerate again. It's not falling at terminal velocity anymore or at a constant speed. It needs to accelerate again. So it doesn't drop the whole distance, only a little bit. Okay, so this might be getting like a little bit much. Let's just record everything. Why think about it? Let's record everything. Let's make it easy on ourselves. So we want the position, the rotation, the scale, velocity, angular velocity. And now we can like simulate everything again how it was. This works in a way fine, but you gotta keep in mind we're recording all these things every frame, so it's not a little bit of data. It's a lot of data. If you want to go 10 seconds back at 60 FPS, like it goes fast. 5 minutes gameplay, 10 minutes gameplay. This is a lot of data. Keep it in mind. So this ball, what can we keep the same? Okay, in our game, the scale is not going to change. So why store the scale? If it's a constant, we don't need to know it. It will be the same. It's never going to change. We don't need to record it. That's already 3 floats of data we don't need to use. Every frame. That's a lot of data. In this case, if you think a little bit further, it's a perfect circle. It's perfect blue. It's uniform. So rotation. We don't need rotation in this case. But I want to make sure that you don't immediately like implement this code in and be like, oh yes, we don't need to store rotation. It's only because it's a perfectly uniform circle. Because if there would be like a red dot on it and you move it like this, if we rewind it and don't do the rotation, then the dot will be on the wrong side. So only because this is a perfectly blue circle is the case. If there would be a dot, a texture, an irregular shape of it, you need to store the rotation. So maybe not store everything, but be smart about it. Think about which values will change over time. During your game, like if it's outside of your game, don't care about it. Just think about during your game. But also, can certain values be deduced? What I mean by this is if you have, for example, a timer and you have a start time, a time left, and a duration. Maybe you want to reuse the timer so the duration changes. If you want to start it a couple times, then you have different start times. And the time left is very interesting to have because you need to know how long is still needed. But with those 3 pieces of data, you are actually storing too much. You don't need to store the time left. Because if you have the start time and the duration at a certain moment, so this is the start time, the duration is going to be till here, and we're currently at this moment, then this is the time left. So think a little bit about your data and be smart about it. You don't need to store everything. Which values will change, which can be deduced. A little bit more of an advanced way of rewinding, or at least the data management in the rewinding, is if the time goes forward, just store values that change. If you're laying on the ground, you don't need to store that it's laying on the ground. Like the position is not updating, it stays the same. So keep it the same. So back to the ball. This is going to be the big example throughout the presentation. So I hope you fall in love with the blue balls. But the ball is dropping here, dropping further, and it hits the ground. If I go another frame forward, you won't see any change, but I'm actually pressing the button. This is a new slide. This is a new frame, but we don't store anything new, and the ball is still in the same position. It's still in the same position. I pressed again. Nothing is changing. This is fine. Like we stored already like 2 floats, or in this case 2 positions. So actually 6 floats of data that we didn't need to store in those 2 frames. Okay, but what if we go back in time now? What if we rewind? Then we look in our buffer and we go to the previous value. So it moves up. But that's not correct. Because it was laying on the ground for 3 frames, or at least 2.5, I want to say it. It was laying on the ground for a bit. We need it, if we rewind, to still lay on the ground a bit. So this is incorrect because it immediately moves up. Okay, so how can we solve this? Easy way to think about it, just save with your data. It's a timestamp, a frame number, or a number of seconds till the start of the game, or something like that. This is one float you're adding, but it can save a lot of data. So by adding this float, we're currently looking at frame 5, position 0, but we're on the ground already for a couple of frames. So we're at frame 7. So we are at the end of the buffer before, but we saved these 2 values. So we're now going back in time. We're going to frame 6. What value we need to look at is in the buffer that we have, the highest frame count that is before the frame we're on. So in this case, we are on frame 6. So we look at the buffer, and the highest number in there is 5 for the frame count. So that's the previous value. Since frame 5, we have been laying on the ground. So the position has been 0. So we just put in set to the ball position 0. Everything's fine. It still lays on the ground. If we go one frame further, we actually do see frame 5 in our buffer. So we can directly put in the value of 0 to the ball. Still lays on the ground, still as expected. If we go one more frame, we go to frame 4. It's also in the buffer, and we move one up because that's the position it gives. So this is the behavior that we want. And for the on-change buffer storing to work, we need to add that frame count or timestamp. It's the same, different way of working. Because with that we can save all the data when things are laying on the ground. Or if you have a flag, for example, that only changes every so often if the object is active or not. Those kind of things. Don't need to store them continuously. Alternative way of a more advanced rewinding is, why do we want to store values every frame? That's a lot of data. If we only do it every second or even every other frame, we store already half the data. And at 60 FPS, if we only store every other frame, that's so much data you're saving. You need to keep in mind though, on the playback, you also need to then do in the same frequency, set it back. Otherwise it doesn't work. It will get into a mess like before. So what it would do is you store the data in this frame. Then the next frame, you don't store any data. So the ball has dropped, but we have not added anything to the buffer. Next frame, the ball has dropped a little bit further again. So we add it again, because that's the old frame again. It's like 1, 2, 3. Third frame, we need to add again. Next frame, drops again, we don't add anything. Drops again, we need to add it to the buffer again. Drops again, hits the ground. Don't need to do anything. And we need to store again. So now we're storing half the data, and we can still reconstruct the movement. But the thing will be that if we now rewind, we also do it every other frame. We set the position because we only have it every other frame. So if we go back in time, the first frame you go back in time doesn't do anything, because that's the frame that we were not recording. So it's also a frame we cannot rewind to. Okay, but the next frame, it moves up again. Fine, we had data, everything's fine. Next frame, it stays in the same location. Okay. What you can see now is that the rewinding, like playing forward, everything goes fine. It still goes smooth. You only store every so often. But on the playback, you actually can see this behavior, that it's more jittery. It moves from one location to another. The bigger you make the interval that it saves data, the more jittery the ball will be moving, or player, or spell, or rock, or whatever you are recording. So keep this in mind. Like, it moves very jittery right now. And before it moved way more smooth. It just went back the same way. So, okay, is this then a bad method of working? No, it doesn't have to be. You just need to be smart. I'm sorry I've been saying that a lot, but you just need to like think a step further. Can we calculate it in a cheap way? Well, instead of time going back every X seconds, or in our case, every other frame, we wanted to go back every frame. We want it to be smooth. We don't want to like wait and have things at the same position. It's a waste of time. It looks ugly. We don't want that. We want to go back every frame, but still store only every other frame, or every X seconds. So you might say, let's just add the times back again. That worked before. It worked fine. We know the time that the event happened. That worked fine. Let's do it again. Okay, we're gonna do it again. We are at frame 6. It's on the ground. Everything is fine. We go back to frame 5 and we move to the highest previous value in the buffer that's not beyond us. So currently we're on frame 5. 6 is beyond us, so we don't need to care about that. 4 is before us. Let's set our value to what is in the 4th position. That's 1. Set to 1. Now we move to frame 4. It still stays in the same location. We have generated exact same behavior as before. Nothing has changed. This time buffer has not added anything to it. It's exactly the same. Okay. But before it worked, why doesn't it work now? Because there's more interval. You just snap it back to the previous location. You snap it back, you snap it back, you skip. You don't make anything smoother. Nothing has been changing. Okay, you can do average and then it would look a little different, but the effect is the same. You would still, like, if you're on 5, you can pick 6 or 4, like it's beyond or before. It still is not correct. What you can do to solve this is use interpolation. For example, linear interpolation, but there are many ways of interpolation you can do. And some work well in certain situations, some work well in other situations. That's beyond the scope of this presentation. I'll just be talking about linear interpolation because generally this solves a lot of the problems and makes everything look smoother. So if we would want to get the data that would have probably been on frame 3, of course we're making estimates now. It's not what actually was there. We're making estimates about the data we have. So at frame 3, we're exactly between frame 2 and frame 4. So what we can do is get the position from frame 2, that's 3, but only take it for half, because we're already half away from it. So instead of 3, we take 1.5, and the same from frame 4, so instead of 1, we take a half. So then 1.5 plus a half is 2. So at frame 3, we're going to say that the ball was at position 2. In this case, it was exactly at position 2, but that's just because of the constant velocity that the ball had and the movement and no influences of other things. But often, in a lot of cases, it generates a pretty good prediction. So let's use it on the balls. We're on position 6. We want to go to frame 5. So we do an interpolation between 4 and 6. So half of 1 is half, plus half of 0 is 0. So the ball moves up by half. Note that this is never a position that the ball was actually ever at. Well, during the falling, during the continuous motion, it would have passed it. But in our frames, it has never been here. But it's a good estimation. Go back a frame further. It goes to position 4, frame 4, it goes to 1. This is position we have set. We know the ball was here exactly. This is fine. We want to go to frame 3. Now we need to interpolate between 3 and 1. This example I did in the slide before. And it moves to the correct position of 2. This way we can make it a lot smoother. It's not the jittery behavior where it's skipping moments, but it's smoothly going over the data. It might go to positions where it has never been, but if it's good enough, why care? Good enough is really more than enough for a game. It is not a physics simulation where it needs to be precise and exact. Good enough for games. As long as you can fool yourself and the people that are playing it that it was there, it was there. And at position 2, of course, it's back at the normal position. So there's now a couple of options that I gave you how you can more efficiently store your data and you can use it to rewind time. So quickly think about what the variables are going to do over time. And depending on what they're going to do, pick the right method. Because not for every variable, every method works. If it's a position of something that keeps moving all the time, yeah, on change is not going to change anything. It just adds more data to it. Be smart about it. Not every value needs to use the same method. maybe position uses one, and timers use another way of working, and rotation use another way of working. Like, be creative and think about what your data needs, and also combine them. Combine on change and on interval to store data. If a ball is falling, on change is not going to change anything, but the interval makes it cheaper. If it's on the ground and stays on the ground stationary, on change will save you a lot of data, while the interval will still collect stuff. Be smart about it. Quick way, like a quick leap forward, is extrapolate. With all this data that we have, we can think about where things are going to be in the future. We can make assumptions. If a ball has been falling at a constant speed for a while, and you need to know where it's going to be in the future. Well, we have a lot of data. We know where it's going to go, or at least make a great assumption about it. Again, this is outside of scope for this presentation, but use the data in creative ways, and you can do so much more. If we look back, though, at the original definition from Wikipedia, we only talked right now about continued progress of existence and didn't talk about events. Well, there's also timed events you can do. Momentary things that just happen shortly, that are most of the time bigger or more complex. The ball just turned into a square. That's not a continuous progress. It just happened like this. So we don't want to store it over time. We just want to pick the moments. So what you need for a timed event is literally a moment. When did it happen? You need a forward action. If the time is moving forward, what should this timed event do? But also, of course, we can go back in time. So we need to be able to reset it back into a circle. Be smart about it again, because you need to reset only the things you need to reset and not anything more, because if you reset too much, you might get into problems. I'll skip this for now. The presentation should be released later on, so you can still look into this. But this is about the local rewinding and the global rewinding, how we incorporate it into one timeline. Quickly goes over it. The ball is falling, everything's fine. We're locally rewinding it. So global time, the green squares are moving forwards, but the arrow is where we locally are playing right now, is moving backwards. So we're looking at old values, but in the world, in actual time, in the simulation, it is still happening. So we need to record those values. We go back further locally, and we're done. We're playing again. We now added a nice blue arrow. The blue arrow is just there for local rewinding, because if we go back right now from the position height of 3, we rewind further. We go to 4, back to 5. We don't do the local rewinding again. That has already happened. We need to skip that. But in the global rewinding, if the whole world globally rewinds, the local rewinding has to be undone. That's why we store both of them. So this is just to keep everything on one timeline, so we don't have to split it into multiple timelines and keep it more clear. So yeah, if we go from here, if we go back in time, we skip over the blue arrow, because that's all local time. We don't need to care about that. That has already happened, or that has never happened in local time, only in global time. And we continue going back, and then we play forwards again. So we have another blue arrow. But what if we globally rewind? Then we need to just skip over the blue arrows. Blue is just for local rewinding. We don't care about it. We just need to go back in our buffer and go back. We're now undoing the local rewinds. It's a bit abstract, so let's go back to the blue balls. Make a quick example of it. The balls drop. The world is simulating. The right ball, we're going to locally rewind, so it moves up again. We play in global time again, so it falls again. Everything is fine so far. We globally rewind now. So the falling that happened after the local rewind is now being set back. We're still global rewinding, So the local rewind is being undone. So both are back at the ground again. And now we continue global rewinding and both balls go up. I went quickly through this. This is a really big part to make both the global and local rewind work in one timeline. The presentation should be available after the talk. So be sure to look into it more. And if you have any questions, feel free to ask me too. I quickly want to talk about the synchronization because it's a very important part. But it's not that big. The rewinding is way bigger. Because the synchronization is similar to playback. We get data from an external source that describes where something is going to be. Basic networking. It just sets the values. Okay, but if we then rewind and we keep a buffer of the object and we set values and from externally we set values, then it gets a big mess because wrong values will get stored. We have race conditions. And it will get an exponential error because things get recorded again and it just gets a big mess. We don't want this to happen. So how to solve this? Objects that you control, like you as the player, or spells that you cast, you keep your own timeline of them. And they're the exact timelines that you can use when they're being rewinded again. You set those values, you control those objects, they are yours. You shall also send all the data about it to the other players. For other objects, for example, other players, other spells, rubble, things like that, you keep a timeline because you do want to know where it was. So you can make predictions about it, about the past, you can set things back, get previews, things like that. But you don't actually set the values of those objects. You don't control them. You just store some data from it. You just learn from them. And from externally, the other players or server will have the timelines and set the values. They will control it and they will say what they will be. You just accept that. You be like, oh, it was there. Okay, it was there. You don't care about it. You just do it. Okay, but you kind of want to make it smoother because if it's like that, you have slow reaction times of other objects that are in your world. It happens jittery because you don't want to synchronize every frame. You want to do it slower maybe. Don't congest your network. It's a whole different talk to go into the whole networking, so I will not do that. Please just look into some basic networking and think about how you can combine it. But an easy thing you can do is separate the graphic, so the model and the animation and things like that, from the actual object, from the player or from the rubble. If I have the ball dropping, I can have everything in one, but then if I get a call from externally like, no, it was there, then it will like jitter up again and things like that. It's kind of ugly. So what we want to do instead is separate the graphic from the ball, and then if it falls and it's reset, then the ball itself, the object behind it, is reset, and you can interpolate the graphic back to it. But in the meantime, like, it might just slow down and fall then again. It will look a lot better, a lot less jittery. Again, you can think about like tweak some values about how often you do that. And you might want to keep an actual timeline of the graphic, but just about position, rotation, and that's all, maybe scale. You don't need any other information because it's just the visual of it, and you want to set that correctly, and then you can react fast and make it look pretty and snappy. And click somewhere else. Here. Well, that was my talk. 1644. I think I did it within time. If you're more interested in Timebenders, be sure to join our Discord. You can also join our closed beta right now and play the game for yourself. Feel free to add me on LinkedIn if you have any questions that you didn't get to right now, because I'll have some questions. And I'll also be in the open talks for a bit, so feel free to hit me up there too. Be sure to speak English because my German is abysmal. Thank you.
Thank you, Thin. That was a great talk. I have to say, the little monkey in my head had to really work his way through all the rewinding back and forth, all the time lines. Really interesting, really interesting. I have to say, the first time I came in contact with time travel in games where life is strange, and I thought that was difficult, but this is next level stuff, I have to say. Did you have to study some physics basics about time or gravitation for your game? Or was it like more natural logic that you adapted into your games?
Well, in general, for game development where a physics simulation is a big part of it, you do need to know at least the basics, some vector math. You need to be able to draw some things out, understand how velocity and angular velocity work and things like that. But if you have a basic understanding of that, then you should be able to do a lot of these things. Yeah, you just gotta like try things out too. Like, don't go too deep into the theory. Try some things out, see how it works, and then you learn really fast. I gotta say it like that too.
Okay, so sounds interesting. Maybe you can like talk about a bit that in the open talk. Maybe there's some more questions. First of all, so what do you like the most about like game developing, also like indie game developing?
Well, currently it's an indie game studio. We would love to grow a little bit bigger because we have really big ambitions for the game. Personally, I actually prefer more of the production side. So I think it's very important not to be naive. Like, yes, you hear some stories about like one-man studios creating like amazing games like Stardew Valley, for example, but you cannot create Stardew Valley like easily like this. Like, it took him a long time. Like, you need to pay rent. Like, you don't live for that long on your mom's attic. Like, I know she loves you, but she wants you to move on for some time too. Be realistic about running a company. The game is just a product of it. I don't want to discourage you, but I just want to make sure that you make it and you don't end up after like 2 years with like massive debt, and you finally get your game to the world, put it on Steam, and then you don't make enough money and you have to get a normal job and your dream goes up into nothing. Like, make sure that you look at the risks, get maybe a couple of actual like business people in your team that are more oriented on running the company itself, so you then can focus on creating the game that you want to make.
So having more like a realistic starting point of the whole thing, not like being really optimistic and have like a purple glasses on it.
It can work. I've heard some success stories about it, but especially if you want to have like a little bit of a bigger team. Like, if you're on your own, it's different. But also be realistic about the scope then of the project. Like, you still need to make your rent, so maybe you need to do some work for hire. You need to do work part-time, side job, something like that, to keep it going.
Okay. So some questions also from the chat from Mochi. She's asking, how's the game industry or community in the Netherlands? Is there like funding from the state?
Funding from the state is a painful subject for game industry in the Netherlands because there's literally none.
Okay.
There used to be one fund only for story-driven games, but as far as I'm aware, that's finished right now. They're currently working on like looking into some options to create some new funds, but the government help is not really there. But the community, the industry itself, the Dutch game industry is a really friendly community, really welcoming, especially also to indie studios. So yeah, you just need to look at other companies. Like, what we also do is ask some other companies, some more veteran companies, like, oh, how have you done like made a publishing deal? How have you done a Kickstarter? Feel free to ask. Generally, people are really open and would love to help you if you have any questions. Like, don't be shy. You don't have to reinvent the wheel yourself.
Okay. So we have the two more questions from the chat. One from Leo. She's asking if you think about character design and smart use of data. How minimalistic can you go with your character design? So you talked about that models already that you applied, but did you have to take out a lot of details of your characters for that?
Well, the details of the characters mostly like just rendered locally. You don't have to like save a lot of data about it. If you do, for example, some clot simulations, clot physics, we've done it, we've implemented it, and it literally showed like just let it simulate while time goes back, still works fine. The same with audio. We don't rewind audio because audio backwards is either sounds really disgusting or it's made in such a way that it works, but then it still often it sounds off. It sounds weird. It doesn't feel well. So we are more often just using continuous looping sounds, things like that. The game sound stays continuous forwards. Just a couple of things like that. We worked on it. But you don't have to rewind everything. As long as it looks good enough, you don't feel like it's off. It's fine.
Yeah, makes sense. I think rewinding sound would be like a bit over the top, like producing sound that would fit that circumstances. Would be also quite expensive, I think.
There's people that do it, but our budget is not available for that.
Okay, I can understand, like, as an industry, that's the reason, true. Last question from Major Tom from the chat. It's more like a technical question. I hope you can help there. Why do you take the velocity from before the rewind instead of the calculated velocity from either the last two rewinding frames or the last two frames that were stored before the rewinding stop? If you want, I can repeat that.
Can you repeat it?
Okay, I do it a bit slow. Okay, so why do you take the velocity from before the rewind instead of the calculated velocity from either the last two rewinding frames or the last two frames that were stored before the rewinding stop?
If I understand it correctly, you say why do we use the velocity before the rewinding happened instead of after the rewinding happened, in a way? If that's the case, then of course the simulation would be wrong afterwards and it would be incorrect. If you mean it in a different way, please hit me up in the open talks and we could talk more about it. Another thing is that your solutions do a lot of calculations in it. It's simple calculations, but you want to use as least calculations as possible to make sure that it's cheap to rewind, because getting all the data from memory is already like not really good for your computer. Your computer doesn't like that.
Yeah.
Because it needs to go from your RAM to your registers and then needs to be put like calculated again to render it. So the less number of calculations we have to do on things, generally the better. But please hit me up in the open talks or on LinkedIn or something so we can talk more about it if you want to know more. So
Major Tom, I think best idea would be to go on the Discord to have like a conversation about physics and some acceleration here. I can help you there too.
Yeah.
We have one more question from the team, so that is a really interesting one and I think really hyped up one. Which class do you prefer playing in ESO?
Well, I don't know, like, it's a hard question for me to answer actually, because I really like to play as a healer or more support. And okay, my main is a Templar, but that's just for PvE content. So like for fighting bosses and trials and things like that. But if I'm in PvP, I way more prefer going as a Nightblade. Just go invisible, throw some heals down, go invisible again, run away. Like nobody can catch me and I can keep my team up. So it depends on the situation, but for PvE, Templar, and PvP, Nightblade for sure.
I hope that answered the question. I have to say I'm out of ESO. That's not my game. I'm sorry. But
it's great. You should try it.
I'm more like the HOTS player, and I recently hit up on chess again. Call me a nerd, but yeah, that makes fun.
No, don't call it a nerd. It's a smart game for smart people, right?
That's true. That's true. But I think that altogether sums up the question about that really interesting talk about time travel. Yeah, so I hope we could help you there. Thank you, Finn, for your talk, for all experience.
Yeah, no worries.
And thank you for being here.
Thanks for having me.